Ever wondered how weather forecasting, stock market predictions, or even predicting a country's GDP is done? The key lies in time series analysis. This, my friends, is a powerful statistical technique that deals with the analysis of time series data, or trend analysis. Now, what does that mean? Well, it's all about studying a series of data points collected over time to identify patterns. These patterns or trends, once identified, can be used to predict future events. Yes, you heard it right. It's like having a crystal ball, but backed by data and science. Whether it's predicting tomorrow's weather, next week's stock market trends, or even a country's GDP in the next 5 years, time series analysis is the secret weapon behind these forecasts. So, are you ready to dive deep into the world of time series analysis and unveil its secrets? First things first, what exactly is time series data? Well, that's a fantastic question, and the answer is quite straightforward. Time series data is a sequence of numerical data points in successive order. It's like a breadcrumb trail where each crumb represents a point in time. Now, let's take a moment to differentiate it from cross-sectional data, another common type of data. Imagine a snapshot, a moment frozen in time where you're gathering data from multiple sources at that one instance. That's cross-sectional data. The key difference with time series data lies in its continuity. While cross-sectional data is like a single snapshot, time series data is akin to a movie, capturing changes over a continuous period. With time series data, time is a crucial factor. The data points are collected at adjacent time periods, be it every second, every minute, every day, or even every year. This sequence creates a chronology that is integral to understanding the patterns and trends within the data. Let's consider an example. Imagine tracking the daily temperature in a city over the course of a year. Each day, you record the temperature, and these recordings, in order, form a time series dataset. This dataset can then be used to analyze patterns and trends, such as seasonal changes or unexpected temperature spikes. But why is this important? Time series data allows us to forecast future events based on past behavior. It's like having a crystal ball that uses historical data instead of magic. By analyzing the patterns in the temperature data, we might predict a heat wave or a particularly cold winter. So, in essence, time series data is a collection of numerical breadcrumbs that lead us through the path of time. It's a story that unfolds over time, revealing patterns and trends that we can analyze to predict the future. So, time series data is like a story that unfolds over time, and time series analysis helps to make sense of this story. Now that we know what time series data is, what are the components of time series analysis? Let's dive into the 4 primary components of time series analysis. These are trend, seasonality, cyclicity, and irregularity. Each of these components plays a significant role in shaping the analysis and understanding the hidden patterns in our data. First, let's talk about trend. This is the overall direction in which the data is moving. Is it going up, down, or staying steady over time? For instance, if you're analyzing the annual revenue of a company, a positive trend might indicate increasing yearly profits. Next, we have seasonality. Seasonality refers to the predictable and recurring patterns that occur over regular intervals. In the retail industry, for instance, sales may spike during the holiday season each year, displaying a pattern of seasonality. The third component is cyclicity. This is similar to seasonality, but the patterns don't occur at fixed, regular intervals. Instead, they're affected by circumstances that don't follow a set schedule. An example could be the economic boom and bust cycles, which don't have a fixed period. Lastly, we have irregularity, also known as the residual or random component. This includes all the fluctuations in the data that can't be explained by the trend, seasonality, or cyclicity. These could be caused by unforeseen events like natural disasters, sudden market changes, or any other unpredictable factors. Understanding these components allows us to decompose our time series data, examining each of these elements separately. This way, we can better understand the underlying patterns and behaviors in our data. By tweaking and refining these components, we can also improve the accuracy of our forecasts. So, remember, trend, seasonality, cyclicity, and irregularity. These are the key components that help us unlock the secrets hidden in time series data. With these components, time series analysis becomes a powerful tool to understand the underlying patterns and make accurate predictions. Time to get our hands dirty. What are the steps involved in time series analysis? In order to unravel the mysteries of time series analysis, we need to follow a systematic approach. So let's walk through the key steps involved in this process. First things first, identifying the problem. It's crucial to understand the business problem at hand and the questions that you're trying to answer. Are you trying to forecast future sales? Predict electricity demand. Once you've identified the problem, you can start thinking about the kind of data you'll need. Next, we move on to the data gathering phase. Time series analysis requires historical data, so you'll need to collect data points at regular intervals over a certain period. The more data you have, the better your analysis will be. Once you've gathered your data, it's time to visualize it. A simple line graph can help you see trends, patterns, and anomalies in your data. This initial exploration can provide valuable insights and guide your next steps. Now we're ready to decompose the series. Decomposition involves breaking down your time series data into its component parts: trend, seasonality, and residuals. This step can help you understand the underlying patterns in your data and prepare it for modeling. Next, we build the model. This is where we apply statistical methods to create a model that captures the patterns we've identified in our data. There are various models to choose from, such as ARIMA, SARIMA, and PROFIT, each with its own strengths and weaknesses. So it's important to choose the one that best suits your data and business problem. Finally, we check the model. We use various diagnostic tools to assess the accuracy and reliability of our model. If our model isn't performing well, we might need to revise our approach or try a different model. Remember, each step is crucial, and skipping one might lead to inaccurate predictions. So, where do we use time series analysis? Well, the applications are broad and far-reaching, touching almost every field you can think of. Let's delve into a few of these areas. In the world of economics, time series analysis is a cornerstone. It's employed to understand economic trends, predict future economic conditions, and evaluate policy impacts. For instance, it helps economists forecast inflation rates, unemployment levels, and GDP growth, assisting in strategic decision-making at both micro and macro levels. Switching gears to business, time series analysis plays a pivotal role. Businesses use it to analyze sales trends, forecast future demand, and manage inventory levels. They also rely on it to predict customer behavior, plan marketing strategies, and make informed financial decisions. For example, a retail company might use time series analysis to forecast product demand during holiday seasons, ensuring they have enough inventory to meet customer needs. In the realm of social sciences, time series analysis is also a powerful tool. Researchers use it to study patterns and trends in various social phenomena over time, like population growth, migration trends, and changes in public opinion. For example, demographers might use it to predict future population sizes and the social implications of these changes. And let's not forget the physical sciences. Here, time series analysis is used to understand and predict natural phenomena. Meteorologists use it to forecast weather patterns, astronomers to track celestial movements, and geologists to predict seismic activities. For instance, time series analysis can help predict the likelihood of a hurricane in a particular region, aiding in disaster management and planning. From monitoring health patterns in medical research to predicting traffic flow in urban planning, the applications of time series analysis are truly diverse. It's a powerful tool that helps us make sense of the world around us anticipate future events, and make informed decisions. From predicting stock prices to forecasting weather patterns, time series analysis has a wide range of applications. We've covered a lot about time series analysis today. Let's recap what we've learned. We began by understanding what time series data is, a series of data points indexed in time order. It's like a fingerprint of past events and a treasure map to future possibilities. We then delved into the components of time series analysis: the trend, seasonality, cyclicity, and irregularity. Think of it like a 4-piece jigsaw puzzle, each piece revealing a different aspect of the data. Next, we walked through the steps involved in time series analysis: identifying the model, estimating parameters, diagnostic checking, and forecasting. A 4-step dance that brings us closer to the heart of the data. We also touched upon its diverse applications, from forecasting stock prices to predicting weather patterns and even understanding human behavior. And that's a wrap on time series analysis. Now, you're equipped with the knowledge to understand the past and predict the future. Until next time, keep learning and stay curious.